Woohoo! Welcome back. Tonight we're going to be talking more about graphs of functions. And what I thought would be useful is instead of watching me plot points for hours and hours and hours, I thought I would just give away for free the basic shapes. Woohoo! And again, I would absolutely encourage playing around in Desmos, because Desmos is a really great online graphing calculator which will allow you to plug in these various expressions plus other versions of them, see how things change. Like y equals x. Okay, y equals x, hopefully you remember, this is linear, it's a line. Why is it linear? It's linear because it just has a y and it just has an x. And in fact, this line comes in at a 45-degree angle like this. And it looks like that. So that's the graph right there. I'm going to emphasize it with my blue because blue is pretty. And so then the question would be, well, what does it look like if I have x plus 1 or x minus 1? Or maybe the opposite of x? That's where Desmos comes in. You can play around, try different things. The goal here is that you are collecting effectively vocabulary. It's easy for me to say vocabulary for a language, the language of math. And the more familiar you are, oh my goodness, this is going to be a night, isn't it? The more familiar you are with these graphs, the easier and faster your math is going to go. So this is linear. And y equals x squared is something we talked about in the last video. This is quadratic. And the shape of the graph is a parabola. Linear, the shape of the graph is a line. So what does a parabola look like? Well, and here the thing is, ooh, I left off my x and y. Oh my goodness, points off for me. I encourage you to look on Desmos because, as I mentioned before, I am just tragic when it comes to trying to graph parabolas properly. I try to make them nice and round, but they end up kind of wonky. But basically, it looks like a U, like that. So that's the graph. That's a quadratic. It's a parabola. Now, what things could you notice? Well, you could notice that, like we talked about last time, this is quadrant 1, right? The quadrants. And they're usually written in Roman numerals, but you can consider them in Arabic numerals, the ones that you might be more familiar with. So it goes 1, 2, 3, 4. And a lot of people are like, why the heck does it go that way? And I'm going to leave that excitement to your trig instructor. Basically, I'm just going to say it does work that way. So if you've got a graph that goes through quadrant 1 and quadrant 3, that means that you're preserving negatives. So when you've got y equals x, if x is positive, y is positive. If x is negative, y is negative. So they go together. And when you see something coming like this, it's generally considered an odd function. It also helps that it's x to the first power and 1 is odd. Okay, so what's going on here? In a parabola, we don't go 1 and 3, we go 1 and 2, which is interesting. Because that means when x is positive, y is positive. And when x is negative, y is still positive. And why is that? Well, y equals x squared. Whenever you've got a square, it means that all the minuses get forgotten, right? The square of negative 2 is positive 4. And so that's why a parabola bends up on itself. Okay, so any guesses on x cubed? That is an odd exponent. Seems likely that we've got a 1 and 3 situation going on. And again, you can plot points. I encourage you to plot points or play in Desmos, but basically what you get is you get a slightly skinnier parabola that splits in two pieces. What does that look like? It looks like this, and then it comes down like this. Isn't that pretty? And so we do see that odd behavior, which doesn't mean weird behavior. It means that when x is positive, y is positive. When x is negative, y is negative. Kind of cool. And it's also skinnier because what happens is when you cube numbers, they get really high, really tall, really fast, or really short or long, really fast. So basically, it stretches up more than the parabola does. Okay, any guesses on x to the fourth? And hopefully you said, I bet that's even. And I said, yep. It is, in fact, even. And in fact, it looks just like a parabola that's really skinny. It gets really, really skinny. So it looks just like a skinny, skinny parabola. Or another way to look at it, a lot of times we look at it, rather than that it's gotten smooshed in, we look at it that it's gotten stretched up. So it's a parabola that got stretched, like a la Willy Wonka. And this is an even function. Okay. Dun, dun, dun. Those are our basics for the polynomials, or the powers of x. And now we're going to go on to some interesting ones. This is absolute value. An absolute value, hopefully you're kind of already guessing, wait a minute, I bet that is even. And the answer is yes. Because what happens is you do have that point. So far, all of them have gone through the point 0, 0. So they all start at the origin. This one looks just like y equals x over here. But because y is the absolute value of x, that means y is also positive even when x is negative. So you end up with a v. And what's important to remember is that this has a little pointy part right here. Whereas a parabola, or even this fourth power, it's round there at the bottom. So that's an important distinction. So that's what absolute value looks like. And if you're not sure, graph one, plot some points. Ask a tutor, ask me, we'll plot some points. Look in Desmos, see what it's like. Okay, radical x. This one is really interesting. I've got a cat sitting on my feet, so that's also interesting. She's trying to get my attention. This is going to be very interesting. Hey there, Chime. Okay, so what's going to happen here is when x is 0, y is 0. So we do have the origin again. But when x is negative, we can't graph this because we can't take the square root of a negative number in the set of real numbers. So all of a sudden we have a domain problem. The domain problem is that x better be positive. So we don't have any graph over here on the left. Now, the interesting thing is when y equals radical x, that means that y squared equals x. Right? If you square both sides, that's a parabola, but that's a parabola with x and y reversed. So the graph ends up looking like this. It looks like half a parabola just heading up. Because why is it only half of the parabola? This is an interesting question to ask. Why is it only half of the parabola? It's only half of the parabola because remember, when we do radical, we only choose the positive side. We're not also choosing the negative. So they're actually two halves, the positive and the negative. That's where it goes. Okay. Dun, dun, dun. So for both of these, we got a denominator problem. So do not let x be 0. Also, do not let the pigeon drive the bus. We know that. But do not let x be 0, because otherwise you're dividing by 0 for both of these. Okay, so what do these look like? Well, this is just going to be a preview, because honestly, we are going to study these later on. It's going to be super fun. You're going to love it, or not. But it is going to be super fun. It's kind of cool. Something to look forward to. But basically what I want to tell you is the big difference between these two. And you might say, well, the squared is a big difference because the numbers are going to get smaller, or the denominator is going to get bigger faster. And I would say, yeah, absolutely. But even more interesting to me is that if you have 1 over x, that means when x is positive, y is positive. And when x is negative, y is negative. So it goes down here. And in fact, that's what happens. You get, and in fact, remember we had when we went through domain and range. By the way, that is a terrible sketch. I apologize. These are all sketches, and as they've gone, these are pretty good. This one, that's terrible. Someone should fire me for that. That is just, oh man. Or maybe I'm trying to convince you to go look at Desmos and tell you it's a terrible graph. Remember when we said the range of these was the y also could not be 0? So it's got an interesting thing. These curves, notice how they get close to the axes, but they go, and they don't actually intersect, which is what's important. So y equals 1 over x. It looks something like this. Again, look at it in Desmos. It looks way better than this. And then this one, same thing, range, y can't be 0. Everything's the same, except this time, whenever x is negative, y is still positive because it's x squared. So it looks like this, and it goes a little bit deeper in. And they should match. And that's what this one looks like. So it looks like that one that's a little bit deeper, and that is even as opposed to odd. It's like that in 1 and 2. Okay, so these are the graphs that I would encourage you just to have. If someone suddenly asks you, what does absolute value look like? You'll say it's a V. What does radical x look like? It looks like this weird little half a parabola. What does this look like? Well, you don't know why. I didn't really justify it except to say this is what they look like. And if you start familiarizing yourself with these now, then you'll have a better idea of what you're aiming for when you're plotting points. Now, when WebAssign asks you to plot points, please do plot the points. Don't just guesstimate. This is good practice. I just chose that if I'm going to do a video for you, I didn't think you wanted 4 hours of me plotting points. That didn't seem like the best use of our time. However, you are always welcome to ask me, how do I plot points? Show me. Let's go through it, and I'm happy to do it. But for this one, I decided to take the time more just to familiarize you with these. And then we're going to do something slightly different for this last little piece of this. Dun, dun, dun! Oh, it's a list. It's a list of functions, maybe. And in fact, the question is, which of these define y as a function of x? So let's review what that means. 1x corresponds to only 1y. So the trick we're going to be looking for is, for each value of x, how many answers are we going to get for y? So first one, y equals x squared. Okay, well, we already know this is a parabola. This is why knowing the graphs is helpful, because with the parabola, we can imagine the vertical line test and say, yeah, this passes. It doesn't bend back on itself anywhere. But I can also say, hey, what happens when you've got x equals 5? Y equals 5 squared. This is 25. So each x value corresponds to 1y. Yes, this is a function. Y as a function of x. Woohoo! Now what if we switch it up? What if we say x equals y squared? And this is kind of weird because you're not expecting to see it. So what you may want to do is you may want to say y squared equals x. Okay, so what if I pick x? My x is 4. So what is y? And the answer is, whoa, wait a minute. We've got 2 options for y. Y could be 2, or y could be negative 2. This is not a function. So if x equals 4, that corresponds to y equals 2, or y equals negative 2. This is not a function. Now, preview. It is a function if you consider it x as a function of y. But y is not a function of x, if that's what we're asking for. So this is the output, and this is the input. So it's a little bit weird because there's a lot of interesting language here. And in fact, math doesn't force you to look at things in one direction only. We're just looking at them that way right now to keep things fairly straightforward right now when you're just getting used to it. But as soon as everyone's got their sea legs, then we're just going to start, switching everything around and playing with different concepts. So, but for now, x goes in, y comes out. Okay, what about x times y equals 1? Now this one I think is really hard. I think this one's a lot easier if we divide both sides by x, and then we get y equals 1 over x. And then, again, we can cheat. It's not really cheating. It's using information. I don't know that that's cheating. It's this one. And even though this is a little wobbly, if we look at the vertical line test, each vertical line goes through only one point. So in other words, the graph doesn't bend around on itself. The other way to look at it is I could say, okay, well, if I plug in a value for x, 5, 1 over 5 is 1/5. There's only one answer. What if I plug in 12, 1 over 12? So for each value of x, there is just one answer of y. There's not a plus or minus. So, and then you might say, well, what about x equals 0? And I say, well, yeah, that's a problem. You can't have x equals 0. So that just means it's not in the domain. Pardon me. It doesn't mean that it corresponds to two different values. And that's the important distinction. So yes, this defines y as a function of x. And honestly, at this point, if I were watching this, I'd be like, wait a minute, I'm not sure I've got this. And the answer is, well, it kind of boils down to, if it looks funny, this one looks pretty funny, see if you can find a counterexample, a single x that would correspond to more than one y. As soon as you've got that, bam, you've got it. You've disproved it. It's not a function, as y as a function of x. Okay, so does this look funny? Yes. Normally the x is on the right. Normally the y is on the left. So we can rewrite it. The absolute value of y equals x. So let's pick a value of x. I say x equals 5. So if x equals 5, then I've got the absolute value of y equals 5. So what could y be? Y could be 5, sure. Or it could be -5. Right? Absolute value means take off the sign, basically. Okay, 1x, 2 y's, not a function. So this is going to boil down to, does it look weird? If it looks weird, can you find an x value that corresponds with more than one y? And honestly, these problems are hard. They really are. These can be very frustrating, very confusing, and so give it your best shot. Don't bang your head against your computer for too long. Go ahead, ask for help. It's awesome to ask for help. Ask me for help, ask the tutors for help, ask your friends for help, have a big old math party with the understanding that everything you do to try to understand it is a step towards calculus, which is awesome, right? We all want to move closer to calculus. So, woohoo! You guys survived. Yay! Yet another video. And so hopefully you take a break, take a nap, go do something fun, run around, pet some animals, go see a rainbow, all that fun stuff. Watch a Muppet movie. Why not? It's been a long time since you've seen a Muppet movie, I guess. I'm just gonna guess. You should go watch one. Some of them are really cool. And then I will see you next time with the next video. Know that I think you're amazing and incredible, and I hope you all math on. Woohoo!